One moment, please. That goes away, you switch down this. I'm going to go down this. It's good right now, I think you switch real quick. Oh, but those are picks. Someone I had picks on me and I put them down.
Good to go?
1 second.
Oh, yeah, no hurry.
Oh, I'll find them later, I guess.
I'm trying to find just rock picks.
I have no idea where they're just walked off with them someplace. If anybody sees a set of Sparrow's picks, please bring them to me.
Get a little video issues, so we're getting on that. Let me know when you're setting that goal starting, Reese.
Make sure. Yep, I'm good.
All right. All right, we're after a couple video snafus, we're getting ready to get started. This is the second track for track 2. Up next, we have Julian. He's from Bishop Fox. The talk is Homebrew Censorship Detection by BGP Analysis, and a little bit about Julian. Sorry, Zach, my fault.
Oh, first name.
He focuses on web application and enterprise security, specializing in consulting with businesses of all sizes to develop both technical and policy solutions. He has a strong interest in the relationship between technology and civil liberties, so please give him a warm welcome.
All right, so you're in Homebrew Censorship Detection by BGP Analysis, just so we're sure. The pamphlet was a little mixed up, so it had printed somebody else. So that's what we'll be talking about today. Before I get started, my name is Zach Julian. I'm a senior security analyst at Bishop Fox, and we're a security consulting firm. We do penetration testing and also defensive security consulting as well. I work on the enterprise security team out of Phoenix. I grew up in Clarkston, close to here, and I've lived now out in Phoenix for about 6 years. And I originally went out there to attend college for computer security. So let's get started. A bit of background why I got interested in this topic, first of all. It kind of came out of an interest in the intersection, or the digital intersection in the Syrian civil war. And the Syrian civil war is an interesting conflict from a digital computer security perspective for a number of reasons. One, the prevalence of state-sponsored malware, and overt state-sponsored malware in that conflict, and also the frequency of internet censorship in Syria throughout the Syrian civil war. And this is still ongoing. So this internet censorship by manipulating BGP, we've seen this in other countries as well, especially during the Arab Spring, Egypt, Libya, although there have also been other countries outside of the Middle East where this tactic has been used. So really this project began with the question, how can I alert myself to changes, BGP changes for the Syrian IP space? Specifically, how can I alert myself to when censorship is occurring? And out of that question came SyriaBGP.net. And essentially, this is just, as you can see, for each of the autonomous systems belonging to Syria, it records the latest change for them, it graphs it visually, and then it tweets updates, it outputs updates to Twitter, so people can be alerted. And if an autonomous system goes down entirely, it'll send out a notice saying that that has been knocked offline. But this is just my specific implementation of this BGP analysis, so I'll be talking also about how to apply this to your own area of research. Okay. So before that, let's talk about what BGP is, Border Gateway Protocol. I'll give a brief overview of how this protocol works exactly. BGP is a critical, though underappreciated, component of the internet, and it's critical to the internet being able to operate and route data properly from point A to point B. At its core, BGP is used to exchange routing information between autonomous systems. Now, when we talk about autonomous systems, this is typically an ISP, but it can also be something like an educational institution or even just a very large company that has been assigned a bunch of IP ranges. But typically when we're talking about an AS, we're talking about an ISP. So BGP is typically useful to exchange routing data between independently operated ISPs so that that traffic can get from point A to point B. And it does this by announcing IP prefixes. And this is really the core of BGP's job, is to say, hey, I can route traffic to these IP ranges. And it's important to note when we're talking about BGP, there's internal BGP and external BGP. So some very large companies use BGP internally if they have a very large internal network and they want to figure out how to route data most efficiently within their network. They'll use BGP internally. But for the purposes of this talk, we're talking about external BGP, which is concerned with like internet level routing. So whenever I say BGP, we're talking about eBGP in this presentation. So what's an autonomous system? Autonomous system is just a collection of IP prefixes or an IP range that are under the control of one network operator. And like I mentioned, this is typically an ISP, a university, a government, or a company that just has a lot of IP ranges. Each one of these sets of IP ranges is assigned to an autonomous system, and those autonomous systems are assigned an autonomous system number, or an ASN, by the IANA. So, for instance, at my home in Phoenix, we can look at how AS numbers are assigned. For my home in Phoenix, I'm assigned an IP address from my ISP and pretend it's within one of these ranges. Now, I added the dots there because, keep in mind, within an autonomous system, there can be hundreds of these IP prefixes and these IP ranges. So imagine there's hundreds more above and below these 4 that I've listed. But my IP address is within one of those. These ranges have been are operated by Quest Communications, which is my ISP, and they've been assigned AS209. So I'm using AS209 when I'm at home and traffic is being routed to and from my apartment. So, and finally, let's just talk about what a prefix is. Pretty simple. A prefix is just an IP range, but in the terms of how data is routed on the internet, these prefixes are advertised via BGP at edge routers. So an edge router is just a router that's sitting at the border of an internal network and the internet. And these edge routers broadcast via BGP, hey, I control these network ranges and I can route data to that destination. So typically, there are multiple edge routers announcing the same BGP advertisements for redundancy purposes as well. There's not just one edge router making these announcements. So if all the edge routers that are advertising for given prefixes, if they stop advertising, those ranges are unroutable to the rest of the internet, both to and from. It can't get to or it can't get from the internet. So if we look at this in a graphical representation, say I'm the laptop up there on the top and I need to get to the server down at the bottom, we can see how that routing data is shared among those different ISPs so that my ISP knows that path to get all the way down to ISP 3 there, and I can reach that server properly. And so BGP works by configuring, so these would be peers that would be configured to share data, but then even if you're not a BGP peer, that information is going to be propagated onto the larger internet through the other peers. So even if the router from ISP 3 and ISP 1 are not directly connected, we can see how that data is transferred because it's connected through ISP 2. So when we're talking about censorship, imagine that ISP3 here is a country instead, and if on those edge routers they stop those BGP advertisements and those prefixes are no longer offered, the rest of the internet here has no idea how to get it to that destination. And this sounds difficult to coordinate when we're talking about an entire country to cut off the internet, but it's actually easier than you would think, especially when you consider countries that have state-owned telecommunications infrastructure, or countries that are very authoritarian, or ones where it's just a very centralized control of the internet. Not only is the control centralized itself, but typically these countries are smaller and they only have a couple of autonomous systems assigned to them anyway. So say my research in the case of Syria, it's actually quite easy to not only shut down the whole country, but to monitor the whole country. Since they only have 3 autonomous systems, from their perspective, if they want to shut down the internet, all they have to do is call up the state-owned ISPs. There's no ifs, ands, or buts about it. They just tell them what to do. They just call up those state-owned ISPs and say, hey, stop offering these BGP advertisements. And yeah, when you're talking about a dictatorship-like country, it's very quite easy to do. So of course, something like this would be much more difficult in a country like the United States, where we have a bunch of independently operated ISPs, and the government couldn't easily compel, all of these ISPs to simultaneously stop routing information. But in countries like the Middle East, Southeast Asia, Eastern Europe, in places like that, this is a lot more frequent. So how can we acquire and monitor and analyze some BGP data to detect censorship at home? The routeviews project is a really awesome project out of the University of Oregon's Advanced Network Technology Center. It's at routeviews.org, and this is a project to aggregate BGP data from a bunch of different participating autonomous systems, and this includes governments, colleges, educational organizations, and also ISPs. They all voluntarily contribute this BGP data, and that allows us to get a much more complete picture of the global routing table from these participating autonomous systems. So they update this data every 2 hours. They have a new BZ2 file available, which is about 50 megabytes, and it's available over a variety of formats. So this is great because we can get a lot of new data every 2 hours, which is pretty frequent. So I would definitely recommend checking out this routeviews.org when you have a moment if you're interested in BGP at some point. They also have some other tools to visualize and play with BGP data on their website as well. So how can we use routeviews data specifically? This is just a raw look at what happens when you extract that BZ2 archive. And although that's only 50 megabytes, this is about a 1 or 2 gig, pretty large, just flat text file. So when you extract it, it comes out to be a pretty large file. And you can see, just imagine, I've cut that in the center, but imagine this is just a huge text file. There's all the IP addresses starting from 0000 all the way down to through the routable on the internet IP address space. So we can see there's a couple different columns here. On the far left, we have our IP prefix, that's the range that we are concerned with reaching. The next hop is the IP address of the device making that announcement. So keep in mind in BGP terms, this doesn't necessarily need to be an IP address that belongs to the prefix being announced. Because BGP data propagates across the internet and things learn new routes, this is just some device out on the internet that knows a route to get to that prefix. And so if we go all the way over to path, we can see this is the path from the perspective of that next hop making the announcement. This is the perspective of the best path in order to get to that destination, read from left to right. So for our next hop concerned with those IP prefixes, the top one, from the perspective of 147.2871, we can go to 3130, 2914, and so on until we reach 29256, which is where that 178.253.104 belongs to. So this data is interesting because it gives us a bunch of, oops, go away. Gives us a very complete picture of what the global routing looks like. And then there are some other columns there, but those are less important to our project. And some of those are like Cisco proprietary metrics that they use to determine the best path. But really what we're concerned with is this one on the far right. And specifically, the question we need to ask ourselves when we're talking about censorship detection is how many times is the ASN that we're concerned with, so in this case, let's just again use Syria as an example. There's 3 autonomous systems, so that'd be 3 different numbers. How many times is our autonomous systems used in a routing path? So if we want to think about this just from like a command line perspective, if we just took this big old text file and we grep for 29386, which is a Syrian autonomous system, we figure out how many instances of that popped up. It was 3,840, okay, for that iteration. So how can we use that data specifically? Again, there's our little command. How many times is this announced in a routing path from this 2 hours? And how does that compare to the data that was released by routeviews 2 hours ago? Just some really easy math here to figure this out. Current total divided by the total from 2 hours ago minus 1, and that equals kind of our change as a percent. So let's say in this instance we get a 6% decrease. Now this doesn't necessarily mean that there's like 6% less routability or anything like that, but using this metric we are able, so say there's like a 25 or a 50 or especially a minus 100% decrease. In that case we can definitely be confident that there's been some sort of connection issue or something radical has changed as far as how those routes are configured. So I wrote a Python script just called routeviews-py in order to make this easy. You feed it a comma-separated list of ASNs. It downloads the latest routeviews data. It does that calculation to compare the change. I have it set up every 2 hours, but you can do whatever you want. I recommend 2 hours. And then it outputs this to either CSV or SQLite. And those are just the columns it outputs, the timestamp, the ASN we're talking about, the number of times that was seen in a routing path, and then the change compared to the last iteration. And you can grab this on GitHub. I'll be uploading that once I'm done talking here. It's not up quite yet, but just give me another hour or so. That'll be available to download. And that's just an example from the help thing, how to use it. You can see all you need to specify is the A flag. You specify your autonomous systems, and then the O flag is optional. If you leave that out, it'll default to SQLite. Pretty simple. And this seems like a really simple, like, duh kind of metric, right? But I've noticed it's a very effective way to measure BGP connectivity or internet connectivity over BGP. So for instance, here's some examples, again talking about Syria. AS24814 went down on that date, and you can see that I confirmed this using the BGP tool at Hurricane Electric, which is a really awesome BGP tool if you want to learn more about BGP. And so I was able to confirm that that was accurate that way. Another instance, the Syrian internet went down in 2014, and Renesas also put out a tweet showing that their data also correlated to mine as far as the time and date and whatnot. And this is something I do if you do decide to kind of do this on your own. I would definitely recommend checking out the Renesas. They're now Dying Research, their Twitter, and there's some other Twitter accounts like this that just will put out BGP updates like this. It's quite interesting to follow. So I wish I had more screenshots. There were other instances where I was able to match it up and say, hey, my data was right. But I didn't bother to take a screenshot at the time, so I have those too. So how can we set this up at home? I've been doing this and running SyriaBGP.net off just a $5 a month VPS. Before that, I was just using a spare machine that I had laying around the house. That VPS only has 512 megs of RAM, so you don't need anything fancy to do this. Download the script from GitHub, pick the ASNs that you want to look at. I would recommend, if you have an interest in geopolitics or something like that, look at countries in the Middle East, Asia, countries where again, the internet is centrally controlled and you are likely to detect some sort of disruption like this. And then once you pick out what you exactly want to monitor, just add something like this to your cron tab, and as you can see, this will just run it every 2 hours for the ASs that we're interested in, and it'll output it. And that's how I do it, just use cron tab to iterate it. So. And then set up your own BGP monitoring or something to that effect. You can detect and report censorship. Syria, like I said, is not the only country doing this. I would look at Egypt, Libya. There's other Middle Eastern countries as well. Because of the way that this is output into the database, it's just those 4 columns. It's very easy to take this data again and visualize it in a bunch of ways. For the website, I personally used high charts. I like that charting library. But there's lots of different things you could do to visualize that data. And again, it's very easy to automate this as well, to just push updates to wherever you would like. I chose Twitter. A mailing list or something else like that might be a good option. But you can use your imagination as far as how to report these changes in BGP. So what's kind of next in this area? For one, BGP is not researched often enough, I would say. It's kind of like DNS in that it works, but it's not designed securely, and it's not researched as much as it probably should be. But the same concept and the same script could be very easily modified to detect BGP hijacking as well, which, as opposed to censorship, just cutting off the ability to route, you're manipulating BGP in order to either intercept or to force traffic in such a way that you are able to intercept it or send it to a location that it's not supposed to go. And this is interesting because even a couple days ago it came out that Hacking Team, when people started going through the Hacking Team leaks, it was revealed that the Italian government used BGP hijacking back in 2013 after Hacking Team lost contact with some of their bots. Hacking Team and the Italian government worked together with an Italian ISP to do BGP hijacking, so they were able to recover control of those bots. So that's interesting. It's probably not the first, but it's, as far as I know, the first documented instance of a Western government doing BGP hijacking. So I thought that was pretty interesting. And then, as you can tell, this alerts about BGP censorship, but it doesn't really do much about it. I'm not sure how technically feasible this is. If anyone has comments, I'd like to hear it, but it came to mind perhaps like a modem bank or something like that is hooked up to the system, and if it detects internet connectivity going down for a certain country, perhaps it can open up that modem bank to allow incoming dial-up connections restricted to the country that's been affected by the connectivity. I don't know the feasibility of like restricting incoming dial-up connections or anything like that. But I'd be interested to talk about that if anyone has ideas. That's a bit of information about my company, Bishop Fox. And that's it. That's the script. That's my email address, and follow me on Twitter. Any questions, sir?
Yeah, do you know, you mentioned Hacking Team, do you know if maybe by chance the outside regime was a client of Hacking Team? Have been revealed at all?
Not that I'm aware of. Yeah, and the list of countries that they were working with did come out, and I saw that, but I don't remember Syria being on there. No.
Why every 2 hours? Would you try 1 hour with the rest of the friends?
That's just because the routeviews project, they only put new data up every 2 hours. If it was less than that, I would totally do that. But yeah.
Hi folks, I'm Geek here. Unfortunately, I think we had a video rig freeze or something else screwed up, so we're missing the audio for the rest of this presentation. However, we got most of it, so sorry for the problems.